Hello guys, in this video I want to talk about the class or device layer of object-oriented programming that contains the actuators and sensors. As an example here I want to explain about motor class. In previous videos we defined the necessary interfaces and we need two of them for motor class, iAutoManual and iActuate. As soon as you create motor class with implementing iAutoManual, you will see these methods for motor that are exactly the same methods of iAutoManual. Here also I have added two other methods, fault handler and map, that I explain them later. Actuate_comp is a composition variable that is an instantiation of the feature iActuate implements, and actuate is an instantiation of interface iActuate. In map method, actuate_comp is assigned to actuate. So if we write actuate dot, you will see the methods and properties that are based on the feature iActuate implements. By using this composition technique, you can easily change between the features. For example, if we have another feature like iActuate implement 2, it is enough to assign actuate_comp 2 to the actuate without any other change in the class. In map, we assign inputs and outputs of class to actuate variable. Let's review what I already did for motor class. Motor is a function block that implements iAutoManual. Motor input is an instantiation of structure motor I, and motor output is an instantiation of motor O. As internal variables, actuate_comp is an instantiation of feature iActuate implement, and fault_comp is an instantiation of feature iFault implement. Actuate is the type of iActuate interface, and fault is iFault interface. Here we call two methods, map and fault handler. In map we assign actuate_comp to actuate and fault_comp to fault. Then we need to assign class inputs and outputs to actuate and fault. Start, stop, and coil, in addition to overload fault, reset fault, and fault status. In fault handler, it always calls methods mResetFault and mSetFault. mAutoOff calls actuate mTurnOff method. If there isn't any fault, mAutoOn calls actuate mTurnOn. Otherwise, it calls actuate mTurnOff. mFault is equal to fault status. In mManual method, we call both mTurnOn manual and mTurnOff manual. But in case of mTurnOn manual, it depends on fault status. If there is any fault, it turns off the actuator. And finally, mRunning is equal to coil status, and that's it. Let's go to the other classes. Cylinder implements iAutoManual. In same way of motor, we instantiate the IO structure cylinder I and cylinder O for inputs and outputs of this class. Internal variables are completely the same, and also calling the methods map and fault handler. In map, we assign compositions to actuate and fault, and assigning inputs and outputs. I didn't assign fault status before, so first I add fault status to the cylinder O structure, and then assign fault status to cylinder output. And on the other hand, in this project, I didn't consider manual mode for cylinders, so let's do it now. For manual mode, I want to consider a push button that activates the cylinder to move, and it returns as soon as you release the button. So we add the variable push PB, and then in the cylinder class we define internal variable for rise edge and falling edge of this input. And now I copy the motor manual method and paste it for cylinder manual mode. Compile project. Okay, as you can see, we have two errors, and it says that a property cannot be assigned in an output assignment of a call. So we have to modify the code like this. Okay, compile again, and no errors. Okay, let's review the other methods. Fault handler that calls reset fault and set fault methods. All the other methods are exactly the same as the motor class. Next class is pick and place cylinder that implements IOTO manual. Inputs and outputs are the instantiation of cylinder PPI and cylinder PPO structures. I defined actuate comp as a composition that instantiates the iActuate implement, and actuate PP is an instantiation of iActuate PP. Fault composition is the same as the other classes. Here we can call map and fault handler. In this method, we have to map the inputs and outputs. Actuate PP comp is assigned to actuate PP and fault comp to fault. Detected object signal is assigned to actuate pp.pdetect, and input state number to the actuate pp pstate. In case of pressure fault, or if the grab command is active but it doesn't have any feedback of the detected object, the fault property is true. Cylinder PP input reset fault is assigned to fault pre-reset fault. And finally, we have to assign the cylinder PP outputs grab, move X and move Z. M auto off is empty because in auto mode it always maintains the last state until it receives the new command. but if you want, you can modify it as you want. In M auto on, the cylinder acts based on the state number. Here I defined 8 states based on the sequence function that consists of different states of X move, Z move, and grab. I didn't define any manual mode, and M running was not necessary actually. Next class is machining that implements I/O manual. We have to do instantiation of inputs and outputs. Here the internal variables are the same as motor class. In map method, we assign the inputs and outputs like start, stop, coil, fault, and fault status. All the other methods are as same as the motor class. Okay, the actuators are finished. Let's go to the sensors. In this project, we just have one type of diffuse sensor. Diffuse sensor function block implements I return bool. Diffuse input is an instantiation of diffuse I. The internal variable are detect and detect comp. And in map method, detect comp is assigned to detect, and the input signal is assigned to the pDetect signal property. And finally, mReturn bool is equal to pDetect signal property. Okay, that's all for this device or class layer. In next video, we will talk about the wrapper. Thank you for watching this video.